And thanks everybody for waiting all the way to my talk. Everybody's been telling everyone else how wonderful life here has been and what great work we've done and how wonderful the future is. But every Troy needs its Cassandra, so I will be today's Cassandra. Right. Now, this is me. I got my PhD in 2000 as part of the CMU speech group. I owe my life to a few people over here. Professor Reddy and Rich Stern. My thesis was on robust speech recognition. I also have sort of contributed to some of the systems that we built, the CMU Sphinx open source effort, and the Sphinx 4 Java-based system, which is currently the most popular Sphinx system, was designed by me. But then we need nostalgia. So my life began as something to do with CMU, began in 93. In 1990, a doctor told me that I had 5 years left to live. So naturally, the thing to do is to go into a deep depression and you sit around waiting to die. Then a couple of years later, I realized I wasn't dying. Something had to be done. At about that time, one of my friends came back from CMU saying, you know what? I mean, this is India. We're always behind the times. We used to be. I mean, when you're lucky, we're 5 years behind the times. So they came and told me, you know what they have in CMU? They have a speech recognition system. They were speaking of the Sphinx. So I decided I wanted to build a speech recognition system. There was only one problem. I didn't know what speech was. I didn't know what speech recognition was. I didn't even have a computer. So that's a long distance to go. I had to begin by buying myself a computer. But that didn't help. This was the Windows days before, this was the DOS days before you had Windows. Then you needed something to capture audio with. So I had to go and panhandle an audio card from somewhere, from a Tata LXE. They were just beginning to manufacture these things. And I got one of their faulty versions, but then it went on a different computer that wouldn't connect with mine. So I had to connect these two computers. Then I realized that you needed an operating system that would actually make these things talk. At that time, India had only 2 internet connections. One of them went to this place called Videsh Sanchar Nigam Limited in downtown Bombay. And the other came to this place called Tata Institute of Fundamental Research, where I was. Except that the second line was just hanging there. It wasn't connected to anything because they were waiting for 25,000 rupees to buy a router. So I asked my friend Raju, who happened to be in charge of the machine that connected India to the world, to get me a version of some operating system that could network. I didn't even know what this was. He came back with 40 floppy disks and said, this is NetBSD. But then he also did something else. The machine was something, in order to download the operating system, you had to be logged in as root. And so after he copied everything to the floppy disks, he did a /bin/rm-f/, destroyed India's only connection to the world, and that has been my greatest contribution to the world and life. For 1 week, India had no internet, right? But then, of course, I installed the operating system on my machine, found it didn't really talk to the other machines, so I couldn't go back to Raju for more help. I needed to get on the internet, so I scrounged around, got some NE2000 cards, bombed a motherboard, bombed a floppy disk controller, built myself a router, connected the machine to the world. Then began the task of building speech recognition. I downloaded books and papers and began learning about speech recognition. So in the whole process, I did eventually manage to, the whole process took about 9 months. I did eventually manage to demonstrate India's first speech recognition system in the Computer Society of India exhibition in 1993. I was there for 3 days. Nobody came to my stall, right? And the reason was very simple. They'd sort of peer in. There wasn't anything inside. Everybody else had gadgets. I had one of those old metal tables, a folding chair. I sat there and I drank tea all day. And then on the 3rd day, some gent came in and said, what do we have here? This was the closing ceremony. And I said, why don't you pick up that phone, call this number, make a call. And he kind of booked himself a train ticket. So he was very impressed. And about a few months later, there was a ticket on my table. I was coming to CMU. I had not applied. That's how I ended up at CMU. Well, what was all that about? That's just because I like to boast. The point is, somewhere in between, I discovered the internet because I was getting all of my information off the internet. And I made posts like these. This was actually from 1994, after I came here to CMU. Do FreeBSD, FreeBSD 1.1, or NetBSD support Visa VGA or Visa IDs. So this is one of the benign ones, and I had posted several before this, right? Fast forward 2000, I get my PhD. And one more person I must thank for my PhD sitting right here, my good friend Pedro. But for him, I wouldn't have graduated. So at least not in 2000. And then in 2009, I joined CMU as faculty. A lot of time has passed. I got narcissistic. I decided I was going to Google myself. And so I Googled myself. And guess what? This thing came back up. Right? Wow. So this wasn't the only thing that came back up. There was this one too. So it says, I posted this is on a math news group. I posted a question. And then finally, just to clarify, I said, for those who are curious, yes, this is an assignment problem. Sadly, I am the TA. So I was unable to solve the problem. So I referred to the solutions manual, found the solution was wrong, so I'm asking you for help. Now, here I am back as a professor, and I'm confessing to the world that I have cheated as a TA. But when I posted this, I had no clue that this thing was going to be found on the internet 16 years down the line, right? That is the point. And things were more embarrassing. So when I Googled this, I found more posts. And yesterday I was just trying to make these slides. I thought maybe let me dig up the post that I saw that really started me off on this work. And so I typed in a couple of the keywords that I remembered, and here's what it came up with. Safe search is off, right? So the words I typed in were my name, of course, and the word gynecomastia. This was on a math news group. This was from 1993, where some 14-year-old kid, I was just messing around, some 14-year-old kid posted a note saying, I'm feeling some nodules in my breast, they hurt. I'm embarrassed to tell my mom, what do I do? And so I told him, this is the wrong news group. What you have is called gynecomastia. Go to the doc, but otherwise you're fine. This happens to a lot of people. The point is, it could have been much worse, because I promise you that my friends were not on sci.math. They were also posting using the router I had built from the machine that I sat on. And those posts were available in 2009, right? 16 years after the fact, and I was now working on speech. What were we doing? We were being just as naive as I was in 1993, when I was posting on the internet. Every single day, we are just going on the web, or we're beginning to use voice services. So this, I like to show this picture. One of the most embarrassing things you can do in your life is to see, Zoolander. Except it's actually a funny movie, for some people at least. So you don't want your friends to know that you watched this movie. You don't want anybody to overhear you. You whisper into the phone, You go to Siri, where's Zoolander? You think you're safe, nobody has heard you, you whisper into the phone, it gave you the answer. Guess what? That information is up there on the cloud. It's there now. And in 2050, it will still be there, right? So this means I have the same problem all over again, right? Not only is this stuff on the cloud, there still is that post that I made about gynecomastia in 1993. So we are not thinking of this. We're just freely using these technologies and not worrying about the fact that every time you use these services, you're leaving a little bit of your life and your soul behind. And it's out there on the web for everybody to see. So what can happen? I'm talking about Siri because we've got Alex over here. He can promise all of us that we're all safe, but we're not. So some guy, they have your voice. Some guy can use your voice recordings, or even Siri can, right? What's stopping them? They can manipulate your voice. They can create fake recordings of you. There are videos of, you don't even need the fancy AI. You could just be using a voice synthesizer, right? They could be learning about you. Now stop and think about this. You may call your bank, you're using an automated system, you think you're fine, the bank analyzes your voice, discovers that you're sick, and then raises your interest rate. Do you really want that to happen? And that's one of the more benign things that can happen, right? They can track you. So the scariest thing in the world for you would be to go into an unknown store in an unknown city in a new country, walk into the store and someone says, "Hi, Bhiksha," right? Because I've spoken to some Apple person in Pittsburgh, and that information is now being tracked because the moment I spoke, they knew who I was, and this is possible today. So, and it's nothing specific to Siri. I'm just picking on Siri because Alex is here, and it's not a futuristic scenario. Every time we use our voice, we are leaving a little bit of our print behind, and that voice record is permanent, and it's permanently open to abuse. So while we are being, all Pollyanna-ish, we have to worry about this too, that it's a problem. And when we spoke about this, when I began talking to people in 2009 and 2010, there was an article that on MIT Tech Review with my concerns. And they went out to various places like BBN and IBM and asked them, "Is this really a problem?" And they said, "Nah, he's bullshitting." Because you know what we do? We convert voice to Capstra. At that point, the voice signal is gone. I'm sorry, I can generate speech from Capstra. I don't need to, even if I cannot, I can use those Capstra, put them to a classifier and tell you who has spoken. I can tell them your gender, I can tell them if you're sick. I know everything about you from that recording, right? So the other thing is, okay, we're going to protect everything, we're going to send everything client side. That too is not going to be guaranteed because there are many solutions, many problems where client-side computation is simply not going to be feasible. We need what is called information theoretic privacy, and that is hard. So I've been working on this for several years now. It'll take me another minute to sort of mention the kinds of things that people speak of. The folks at Siri and elsewhere tell you they use something called differential privacy, where you can add a little bit of noise and hide everything. In fact, we had one of the first papers, probably the first paper on what is called federated learning these days, where you could say a lot of different entities or agencies could just contribute to some common shared goal without revealing themselves by adding a little bit of noise. What we found is that by the time you've added enough noise to protect yourself, the system that you're building is useless. It's only good for advertisement. You can have something called homomorphic encryption, which is a mechanism whereby you just encrypt your voice, ship the encrypted voice over to the system. The system only sees the encrypted voice, so it never knows anything about it. And you work in the encrypted domain, the answer is also encrypted. It ships the encrypted answer back to you, and then you can decrypt it. You think you're safe, right? This sounds fantastic. It even kind of works. It slows everything down by a factor of 100,000 on a good day, right? And this besides the fact that everything is going to become really, really inaccurate. So try something else, right? There's the other approach that people suggest, which is called multi-party computation. The whole idea is that you want to distribute the computation across many different parties, where everybody just sees a small portion of what is to be computed, from which the entire thing cannot be reconstructed. But then the result must be the same as if all of them had sent their own parts of the data to some trusted central party who could perform the computations and return it. This works, and this is 10,000x slower in compute and 10,000x slower in communication because you're shipping things around. So where we stand right now is that there are other solutions. People have said, you know what, you're trying to deal with cryptography, and the problem with cryptography is it shatters the space. If I take 2 points which are very close in the original data space, once you encrypt it, you can't say how far apart they are. That's how you're protecting things. But this is what makes computation on encrypted data so slow and painful. Maybe instead of having something so completely discontinuous, I give you a continuous transform, which sort of distorts the data, which still lets me tell you how close two things are without knowing exactly where each point came from. Again, mathematically, you can show that this is a no-brainer. It doesn't work because if I can tell you the distance between any two data instances over a large collection, I can use that matrix of distances, go back and reconstruct the original space. So I haven't really hidden anything. And so all of these can be struck off, right? So where am I? Do I have answers? After 10 years, I don't have answers. Like I said, I'm here as Cassandra. We've enabled abuse, but then that doesn't mean that we can't really use we shouldn't be using these technologies. What I'm depending on is that there are people far, far smarter than me, and there are many, many, many more people than there are in this room. And together we will come upon a solution, but for now we don't have it. It's just something that we should all be aware of. Thank you.